Hello and welcome to the next edition of the BriefingsDirect Voice of AI Innovation podcast series. I'm Dana Gardner, Principal Analyst at Inter Arbor Solutions, your host and moderator for this ongoing discussion on the latest insights into artificial intelligence use cases and strategies. Major trends in AI and advanced analytics are now coalescing into top competitive differentiators for most businesses. Access to advanced algorithms, more cloud options, high-performance compute resources, and an unprecedented data asset collection have all come together to make AI more attainable and more powerful than ever. Stay with us as we examine why AI is indispensable for digital transformation through the look at some deep dive interviews for prominent business use cases and their escalating benefits. To learn more about analytic solutions that support mission-critical use cases, we're joined by two experts. We're here with Andy Longworth, Senior Solution Architect in the AI and Data Practice at Hewlett-Packard Enterprise PointNext Services. Welcome, Andy.
Thank you, Dana.
We're also here with Iveta Lachovska, Data Scientist in the PointNext Global Practice for AI and Data at HPE. Welcome, Iveta.
Welcome.
So let's look at some of the trends that are coalescing around modern analytics and artificial intelligence and why they're playing an increasingly essential role in digital business transformation. Andy, what do you see as some of the top drivers that is making AI much more prominent in most businesses?
I think we've got three main things that are driving AI at the moment for businesses. First of all, we all know about the data explosion. So all these AI algorithms that are using require huge amounts of data. So we're generating that, especially in the industrial setting with machine data. But we've also got the relative price of compute that's coming down. So the ability to process all of that data and accelerators as well. So GPUs, TPUs becoming more available to people, enabling us to get through that vast volume of data. And then thirdly is the algorithms. So if we look to organizations like Facebook, Google, and academic institutions, they're making algorithms available as open source. So organizations don't have to go and employ somebody to build an algorithm from the ground up, but they can start to use these pre-trained, pre-created models to give them a kickstart in AI and quickly understand whether there's value in it for them or not.
And how do those come together to impact what's referred to as digital transformation? Why are these not sort of low-level IT benefits, but actually become business benefits?
So they're allowing organizations to become what we call data-driven. They can start to use that massive data that they've previously generated but never tapped into to be able to improve business decisions that they make. So they're actually impacting the way that they drive the business through AI, and it's transforming the way they work. So if you look at several types of industry, how data is now driving the decisions that they make, industry being one of those, Industry 4.0, pulling in data to help industrial customers or industrial organizations to improve the way they manufacture. And so without processing of that data, these things wouldn't be possible.
And we will look at some prominent use cases, but in still understanding the impact and why things are different, Iveta, but why are these trends that Andy has described making artificial intelligence different now from a data science perspective? What's different now than, say, 2 or 3 years ago?
I'd say most of those AI algorithms existed in the past. I would say most of them are 30, 40, 50 years old in terms of the linear algebra and the mathematical foundations behind them. The new thing is basically the computing power which enables those computations and the amount of data used to train those algorithms. So those two components are changing fundamentally the picture. And the fact that also the taxonomy and the way people start to think of AI and to differentiate between classical statistics and then the deep learning algorithms, and the fact that already not just technical people can interact with those type of technologies and analytical models, but also semi-technical people with a simple drag and drop interaction based on the new products on the market enables them to adopt and fail fast or succeed faster into this AI space. And the models also getting better and better in their performance based on the amount of data they get trained on and the digital footprint.
Thank you. And Andy, it sounds like AI has now evolved to the point where it's starting to mimic human-like behavior and skills using this data, using these assets that we've talked about. How is that different, and how does such machine learning and deep learning change the very nature of work?
It allows organizations and people to move some of the jobs that were previously very tedious for people to be done by machines and repurpose those skills of people in more complex jobs. So if you think about, for example, computer vision and applying that in quality control, if you're creating the same product again and again and again and paying somebody to look at that product and say whether there's a defect on it, A, it's probably not the best use of their skills, but B, you become fatigued. If you look at the same thing again and again, you start to miss features of that and miss possibly things that have gone wrong with it. Whereas a computer doesn't get that same fatigue. So you can train a model to perform that quality control step, and it won't become tired over time, and it can keep going for longer than, for example, an 8-hour shift that a typical person might work. So you're seeing these practical applications allowing the workforce to concentrate on other things.
And Iveta, it wasn't that long ago that big data was captured and analyzed for the sake of compliance and business continuity, but data has become so much more strategic. How are businesses needing to change the way they view their data and how to monetize and invest in it? What's shifted there?
I think that they start to pay attention more on the quality of the data and the variety of the data collection they're focusing on. From a data science perspective, even if I want to say that the performance of the models is extremely important, that my data science skills are critical component into this AI space and ecosystem, the quality of the data and the way data is pipelined and handled during this process of manipulation, getting to the last mile of the data science contribution is extremely important. And I have tendencies to believe that it's the critical step and foundations. And so organizations start to realize that and to be more selective, to pay more attention on the foundations of the way they handle big data or small data till it gets to the data science part of the process. So the maturities, you can already see that there are many customers and partners and organizations paying more attention on the fundamental layers of AI so that they get the better performance at the last mile of the process.
Why are the traditional IT management approaches not enough, and how do the cloud models help in that?
I think cloud brings opportunities for organizations in so much as they can try before they buy, essentially. So if you go back to the idea of processing all that data, before an organization spends real money on purchasing GPUs, they can try them in the cloud to understand whether they work and deliver value for them, and then start to look at the delivery model of, does it make sense for me with my use case to actually make a capital investment in this, or do I just go for a pay per use model using the cloud? And then you also have the data management piece that you asked about, which is understanding where your data is. And I don't think from that sense cloud necessarily makes life any more complicated. You still need to know where that data resides and control that data, put the necessary protections around that data in line with the value of that data or what type of data it is. And I think that becomes particularly important with legislation like GDPR, where a European citizen can ask for any of their personally identifiable information from an organization to not only be played back to them so they know what you have in terms of data on them, but they can also ask you to delete that data. So if you don't have your data management under control and understand where all those copies of that data are, then you can't be compliant with legislation like GDPR that says you need to be able to delete that data if somebody should ask for it. So in itself, it doesn't necessarily bring complexity, but you need to be aware of what you're putting in the cloud versus what you have on premise and where the data resides within your ecosystem.
I think another element of the past approaches to this was a bit more, I guess, particular, right? We talk about the difference between managing a cow and managing a herd. Too much particular makes difficulty in scaling. So how do we reach a balance when we're trying to attain digital business transformation and fully take advantage of artificial intelligence? How do we get a balance between a standardized approach, but also something that's appropriate for specific use cases? And why is the architecture of today very much involved with that sort of a balance, Andy?
The first thing that we have to understand is what is the use case and how quickly do we need insights from that use case. So we can process, for example, data in near real time, or we can use batch processing like we did in days of old. And, the use case defines the kind of processing that we have. So if you think about an autonomous vehicle, you can't batch process the sensor data that's coming in from that car when it's driving on the road. You need to be able to do that in near real time. And that comes at a cost. You need not only the flow of data, but you also need the compute power to be able to process all of that data in near real time. So the first thing is to understand the criticality of that data and how quickly we need to process it. And then we can start to build solutions that process the data within that framework and within the right time that it needs to be processed. Otherwise, you're putting additional cost into a use case that doesn't necessarily need to be there. When we build those use cases, we're typically using cloud-like technologies, be that containers or scale-out technologies, that allow us to have the portability of the use case, even if we're not necessarily going to deploy that in the cloud, because what it allows us to do is to move the use case, move the computing of that use case as close to the data as possible. Use an example, if we're talking about that computer vision use case on a production line, we don't want to be sending the images into the cloud and having a high latency in processing of the data if we need to have a very quick answer to control the production process. So you would want to move the inference engine for that use case as close to the production line as possible. And so if we use things like edge line computing and containers, we can actually put that right there on the production line to get the answer as quickly as we need it. So being able to move the use case where it needs to reside is probably one of the biggest things that we need to consider.
And Iveta, why is an explore, experiment, and an evolve approach using this holistic and widespread ecosystem support approach the right way to go?
Because doing AI is not easy. If it was easy, then everyone would be doing this and we would not have this conversation. It's not a simple statistical use case or a problem or a BI where you already have the answer, or at least you have an idea of the questions you're asking. Also, in the data science title, you have the word science. So there's a moment of research and uncertainty, the way you explore the data, the way you understand the use cases, starting from the fact that you have to define your business case. You have to define the scope. And my advice would be to start small, not to exhaust your resources or the trust of the different stakeholders, but also defining the correct use case and the ROI around this. And this is something very interesting we are also doing at Hewlett-Packard Enterprise, is working on the definitions and the business case when approaching an AI use case, trying to understand what's the level of complexity, what's the level of prediction you need to achieve to solve your use cases. So this explorational phase is extremely important so that everyone is aligned and you find the right path to minimize the failure to get to the success of monetizing data and AI. And then once you have the fundamentals there, once you have experiment with one or two use cases and you see them up and running in your production environment, is the moment to scale them. And I think we're doing a great job to bring all of those complicated environments with their data complexity and model complexity and the whole networking and security and regulations, like just Andy mentioned, different data protection regulations in one environment in production so that this starts bringing value as a use case. So this flow is extremely important. This look of experimenting and not approaching the things like you have a fixed answer or you have a fixed approach is extremely important. And this is the way we as a HPE are approaching the AI use cases.
All right. Before we get into those use cases, it sounds as if we're almost approaching some sort of a unified theory, reference architecture that's very inclusive of systems, cloud models, data management, and the AI services themselves. Is that what's going to be required, Andy? Do we need to have a grand unifying theory of AI and data management to make this happen?
I don't think we do. I think it would be wonderful if we get it, and maybe one day we'll get to that point. But I think what we're reaching is a clear understanding of what architectures work for which use cases and which business requirements, and being able to apply them without having to experiment every time we go into this. Because to complement what Iveta was saying earlier, when we start to look at these use cases, when we engage with customers, what's key to this is making sure that there is business value for the organization. We know AI can work, but the question is, does it work in the customer's business context? So if we can take out a good deal of that experimentation and come in with, okay, this is a fairly good answer to the type of use case that you have in the type of industry that you're working in, then we have a good jump start on that. I think as time goes on and AI develops, then things we'll start to see more generic AI solutions that can be used for many different things. But at the moment, it's really about point solutions.
All right. Well, let's find out where AI is making an impact. Let's look first, Andy, at digital prescriptive maintenance and quality control. You mentioned manufacturing a little earlier. What's the problem? What's the context? And how is this being improved? How are we getting better business outcomes?
When it comes to prescriptive maintenance or predictive maintenance even, the problem is the way we do maintenance schedules today. If you look back in history, we had reactive maintenance, which was basically something breaks and then we fix it. Now, most organizations are in a preventative mode. So a manufacturer gives a service window and says, okay, you need to service this machinery every 1,000 hours of running, for example. And that happens whether it's needed or not. When we get into prescriptive and predictive maintenance, then what we're looking to do is to service those assets as they actually need it. So having a look at the data that comes in from them, understanding the trends, understanding if problems are forthcoming, and then fixing them before they impact the business. And so using lots of data from that machinery, be that sensor data from temperature, vibration, speed, getting that condition-based monitoring view, understanding in real time what's happening with the machinery, and then being able to use past history to be able to predict what is going to happen in the future with that machine. So we can then start to get to a point in time where we know in real time what's happening with the machinery and have the ability to predict the failures before they happen. The prescriptive piece comes in that when we understand the business criticality or the business impact of an asset. And so one of the ways I tend to look at this is if you have a production line and you've got two pieces of machinery on the production line, both have the identical probability of failure, but one's on your critical manufacturing path, the other one has some product buffer. As a business, the way that you're going to deal with those two pieces of machinery is different. You'll treat the one on the critical path different than the one where you have product buffer. And so the prescriptive piece is really going beyond the prediction, but understanding the business context of that machinery and applying that to how you behave and how you react when something starts to happen with that machine. And so that's kind of the idea of the solution that we had when we were building digital prescriptive maintenance. The side benefit that we saw from that is actually the quality control piece. If you have a large piece of machinery that you can attest to it running perfectly during a production run, for example, then you can actually say with some certainty what the quality of the outcoming product from that machine is going to be.
Okay, so we have AI overlooking your manufacturing and your processing. It's probably something that would make you sleep a little bit better at night, knowing that you have such a powerful tool constantly observing and reporting back. Let's move on to our next use case, Iveta, video analytics and surveillance. What's the problem we need to solve? Why is AI important to solving it?
Video surveillance and the video analytics in general, the overarching field is computer vision. And I think this is the most mature and currently the most trendy AI field, simply because the amount of data is there, the diversity is there, and also the algorithms are getting better and better. And it's not anymore so much state of the art where it's difficult to grasp and to adopt and to bring it into a production. So the things are really moving into production and actually being able to monetize those type of data sources. So when we talk about video analytics or surveillance or any kind of quality assurance, the main problem is that you're trying to improve or detect human errors, behavior, environment. Telemetry plays a huge role here. And there are many, many components and many constraints to be considered in this environment, what makes it very hardware dependent and also AI at the edge type of requirements, where most of the algorithms, most of the decisions need to happen at the edge, simply because if you want to detect fire, if you want to detect fraud or prevent certain types of failure, quality failure or human failure, time is extremely important. And we've been working on solution and reference architectures to approach those problems. And I would say a reference architecture and the type of the approach we have to solve the solution is the right one, because the complexity of the environment, the complexity of the different cameras and hardware handling the data acquisition process at the beginning is enormous, and it's very diverse. So there's no one size fits it all. There's no one provider, one solution which can handle surveillance use case or a broad analytical use case at a manufacturing plant or oil and gas ring, where you're trying to detect fire or oil and gas splits from the different environments there. So being able to approach it holistically, to be able to choose the right solution for the right component and design the architecture is key in this component. Also having the right hardware and edge devices to acquire the data, or not to acquire data you don't need, to handle the telemetry around this. Let's say when you're positioning cameras in outside environment and you have different temperatures and vibrations and heat around that. So this will reflect the quality of the acquired information going through the pipeline. Some of the benefits, and I've been working on several use cases within computer vision and within video surveillance, is having the real-time information coming from your manufacturing plant, knowing that all the safety and security standards there are met and the people operating at that plant are and following the instructions and have the safetiness required for that manufacturing plant is extremely important. Also, when you have a quality assurance use case, and Andy already touched on that, video analytics is one source of information to tackle the quality assurance use case. For example, improving the quality of your products or improving the quality of your badges. This is just one type of source which is under the computer vision field. So having this architecture and being able to be agile and flexible and finding the right piece for the right problem and the right models deployed at the right edge device or at the right camera is something we are doing right now, and we have several partners we're working with to be able to solve this challenge of video analytics use cases.
Right. And when you have a highly scaling, high-speed AI ability to analyze this video, it's no longer a gating factor that you need to have humans reviewing the video. It really allows video to be used in so many more applications and even augmented reality, so that you're starting to use video on both ends of the equation, as it were. Is that the case? We see an explosion of applications and use cases where video analytics is being used, Aveda?
Yeah, absolutely. And this was one of the things I see. It's just the amount of algorithms in this space is enormous. Also, all the open source data sets in terms of ImageNet and ResNet, a huge amount of data. You can train any kind of algorithms on those open source data sets and then take them and adjust them and pre-train them for your own use case. Doesn't matter is it healthcare or manufacturing or video surveillance. Is very enabling. And so you can see diversity in terms of the different solutions people are trying to develop and the different problems they're trying to tackle using specifically the computer vision capabilities, not only from algorithm, but also from hardware side, because the cameras are getting more and more powerful. So currently, we're working on several projects where we are working in the non-visible human spectrum in terms of images and environments. And this could be enabled only with the further development of the actual hardware acquiring those images.
Well, if we can view things and analyze them and then work with that to great advantage, as you've described, perhaps we can also listen and talk to them. So tell us about speech and natural language processing of ETA and how AI is enabling that capability and impacting businesses and how they transform themselves.
This is another exciting field of AI, another very strong field of how AI is used and is improving. I wouldn't say it's that mature as computer vision, simply because the diversity and the complexity of human language and speech and the way speech gets recorded and transferred is a bit more complex. So it's not only a problem of technologists and people writing algorithms, but also linguists being able to combine the grammar problems and to write the right equation to solve those grammar problems. But one very interesting field into the speech and natural language processing area is speech to text. So basically being able to transcribe speech into text, and it's very helpful for emergency organizations handling emergency call or fraud detection, where you need to be able in real time to detect a fraud or to detect danger, or if someone is in danger. It's a very common use case for law enforcement or for security organizations, or simply improving the quality of your service for call centers. So this is, for example, industry or vertical independent. So you can have finance, you can have manufacturing, you can have retail, but all of them have some kind of customer support. And this is the most common use case, being able to record and improve the quality of your service based on the analysis you can apply it on the recording. And some of the, again, similar to the video analytics use case, approach we have here is, in order to handle the complexity of different algorithms, different languages, and also different quality of recording, also different techniques to capture recording, is to have a reference architecture where you have the different components designed, and based on the exactly this holistic approach we talked about earlier, to be able to explore, evolve, and experiment in this space, we choose the right component for the right problem and how to approach it. And in this case, if we combine the right data science tool with the right processing tool and the right algorithms on top of it, then you can simply design the solution and solve the specific problem.
All right. Thank you so much. Now, our next and last use case for AI is one people are probably very familiar with or more familiar with, and that's the autonomous driving technology and what it can do. So, Andy, how are we developing highly automated driving infrastructures that leverage AI and help us get to that potential nirvana of truly self-driving and autonomous vehicles?
I think there's several problems around highly autonomous driving, as we've seen. It's taking years to get to the point that we have these fully autonomous cars, and there's clear advantages to it. If you look at, for example, what the WHO says, that there's over 1 million deaths per year in road traffic accidents. So one of the primary drivers is that we can reduce the human error in cars on the road and reduce the number of fatalities and accidents that happen on the road. But to get to that point, we need to be able to train these immensely complex AI algorithms that take massive amounts of data from the car. So if you look at what's going on just purely from the sensor point of view, we have high definition cameras giving you 360-degree views around the car. You've got radar, you've got GPS, you've got audio, you've got vision systems. Some manufacturers are saying they use LiDAR, some are not. But you have all these sensors that are giving you a massive amount of data. And to develop those autonomous cars, you need to be able to process all of this raw data. And typically in an 8-hour shift, a autonomous development car is going to be generating somewhere between 70 and 100 terabytes of data. And if you've got an entire fleet of cars out there that are generating this, then you need to be able to very quickly get that data off the car so that you can get them back out onto the road as quickly as possible. But B, get that data from where you offload it into the data center so that those developers, the data scientists, the analysts, the engineers can start to work on that to build the next iteration of the autonomous driving strategy that they put onto those cars. And when you've built that, tested it, and done all the good things that you need to do before you put the car on the road, you then need to be able to get that model or those models and that strategy from the developers back into the car again. So you have this, I suppose it's like all the other AI problems that we've been talking about, but on steroids because of the sheer volume of data that you're talking about, but also the impact of what happens if something should go wrong with that. So what we've been doing is developing a solution or a set of solutions that address several of the points of that development process in the cars. So first of all is the ingest. How can we use that edgeline processing in the car to be able to pre-process data and reduce the amount of data that you have to send back to the data center, but also be able to send back the most important data out of the 8-hour drive first, and the run-of-the-mill stuff that is just backup data almost later. The second piece is the data platform itself. Building a massive data platform that is extensible to be able to store all this data that's coming from the autonomous driving test fleet, but also expand as that fleet grows and also be able to support different use cases. So that data platform and the development platform is not only massive in terms of the amount of data that it needs to hold and process, but also in terms of the tooling that it needs to be able to provide. So we've been developing reference architectures to be able to enable automotive manufacturers, but also the suppliers of those automotives as well, to be able to build that data platform and provide all the processing that they need to provide to their data scientists to be able to develop those autonomous driving strategies and be able to test them in a highly automated way where necessary, but also giving access to the data to the additional suppliers. So, for example, those sensor suppliers to be able to see what's happening to their sensors whilst they're on the car. So the platform that we've been putting together is really concerned with having the flexibility for those different use cases, the scalability to be able to support the data volumes of today, but also grow to be able to have the data volumes of the not too distant future, and also that speed and data locality. So being able to provide high speed parallel file systems, for example, to be able to feed those development systems and help them train the models that they have. So all this kind of pulls together all of the different components that we've talked about with all the different use cases, but at a scale that is much larger than several of the other use cases probably put together.
Yeah, it certainly strikes me that the autonomous driving technology problem, if solved, enables so many other major issues. So we're talking about micro data centers that can do high performance compute at the edge. And we're talking about the right hybrid approach to the data management, what to move, what to keep local, how to then have a life cycle approach to that. So a really key use case scenario. Tell me, before we start closing out, why is HPE uniquely positioned to solve something like autonomous driving technology that will then lead to so many enabling technologies for other applications?
So I think one of the things is, like you say, that micro data center. You know, every autonomous driving car essentially starts to become a data center on wheels. So being able to provide that compute at the edge to enable the processing of all that sensor data. If you look at the portfolio of products, there's very few organizations that have that edge compute in the same way and the same processing power in those small packages. But it's also about being able to wrap it up in not only the hardware, but the solution on top and the support, and being able to give a flexible delivery model for that. So, you know, lots of organizations want to have a cloud-like experience, not just from the way they consume the technology, but also in the way they pay for that technology. So providing everything as a service and being able to pay for a as-you-use service for your autonomous driving platform. And I think there's very few organizations in the world that can kind of offer that end-to-end proposition.
Aveta, anything to offer on that same issue of why it takes a team sport and a solution approach from the data science perspective to actually tackle these major use cases?
exactly the fact and the way we approach those complex use cases, and the fact that you can have them as a service and not only infrastructure as a service or data as a service, but also working on AI and model as a service approach, where you can have marketplace for models and being able to plug and play the different technologies and experiment and rapidly deploy them and start to get value out of those technology is something we are doing on a daily basis, and we are doing with really amazing experts and people having knowledge on the different layers and attacking the complexity of those use cases from each side, because it's not just data science and hardware, but a lot of domain specific expertise to be able to solve those problems is something we're looking at and we're having in-house. And I'm extremely happy to say that I have the pleasure to work with all of those amazing people and experts within HP.
And there's a great deal more information available on each of these use cases for artificial intelligence. There's white papers available. It's on the HPE website in Point Next services. We can point you to that on our website. So what else can people be doing before we close out, Andy, to get ready for these high-level AI use cases that lead to digital business transformation? How should organizations be perhaps setting themselves up on a people, process, and technology front to start to get very adept at AI as a core competency?
I think, like you say, it's a program, and it's about people, technology, process, and all these things combined. You don't go and buy AI in a box today. So you need to have a structured approach to that. You need to understand what the use cases are that give value to your organization, and be able to quickly prototype those, quickly experiment with them, and prove that the value is there to your stakeholders. But I think where a lot of organizations get stuck is moving from that prototyping, proof of concept, proof of value phase into the fully production phase, and getting the process and the pipelines there to enable you to transition from that small POV into a full production environment. If you can crack that nut, then the next use cases that you implement and the next business problems that you want to solve with AI become infinitely easier. But it is a hard step to take from proof of value through to the full production, because there are so many bits involved. You have that whole value chain from grabbing hold of the data at the point of creation, processing that data, making sure you have the right people and process around that. And also when you come out with, if you have an AI solution that gives you some form of inference, it gives you some form of answer, you need to be able to act upon that answer. You can have the best AI solution in the world that will give you the best predictions. But if you don't build those predictions into your business processes, you may well have never made them in the first place.
Well, great. I'm afraid we'll have to leave it there. We've been exploring how major trends in AI and advanced analytics have coalesced into top competitive differentiators for many businesses. And we've learned how AI is indispensable for digital transformation by looking at several prominent use cases and their escalating benefits. So please join me in thanking our guests. We've been here with Andy Longworth, Senior Solution Architect in the AI and Data Practice at Hewlett-Packard Enterprise Point Next Services. Thank you so much, Andy.
Thank you, Dana.
And we've also been here with Iveta Lachovska, Data Scientist in the Point Next Global Practice for AI and Data at HPE. Thank you so much, Iveta.
Thank you, Dana.
And a big thank you as well to our audience for joining us for this sponsored BriefingsDirect Voice of AI Innovation discussion. I'm Dana Gardner, Principal Analyst at Inter Arbor Solutions, your host for this ongoing series of Hewlett-Packard Enterprise supported discussions. Thanks again for listening. Please pass this along to your IT community and do come back next time.